So in Calc 1 and 2, you looked at functions of a real variable. That is, functions that took a real variable x and gave you a real variable y for an answer. For example, y equals sine x. So the domain of this is one real variable, the range is one real variable. So in this section we'll be looking at functions that take two variables and give you one variable, and functions that take more than two variables and give you one variable for the range. So an example of this first type is, say, f of xy equals x squared plus y squared. So evaluating this at a particular point, say f of 1, negative 2, we would plug 1 in for all the x's, and then negative 2 in for all the y's, and then evaluate. And this gives us 1 plus 4 is 5. We also investigate functions of three variables. So for example, f of x, y, z is x plus 2y squared minus z. And if we were to evaluate this, say at the point 1, 0, 4, we would plug 1 in for all the x's, 0 for all the y's, and 4 for the z's. We evaluate this and get negative 3. So these are functions of two variables and functions of three variables respectively, sometimes called multivariate functions, indicating the multivariate part involves what goes in, the input of the function. So now that we have the idea of a multivariate function down, let's look at the idea of domain. So domain works much like it does in functions of one variable. We want to look for known trouble spots. So these include things like division by 0, log of a negative or a 0, and negatives under a radical. So for example, if we had the function f of xy is the square root of 4 minus x squared minus y squared, and we wanted to identify its domain, we need to make sure that the inside of the radical is going to be bigger than or equal to 0, non-negative. So we'll set the inside greater than or equal to 0, and then we'll manipulate this. Let's move the x and the y over. So we get 4 is greater than or equal to x squared plus y squared. We see that this is the disk centered at 0 of the origin, whose radius is 2. So this is actually the domain of the function. We can't set it down to a single variable. It works in terms of both variables at the same time. So the domain of this function is x squared plus y squared less than or equal to 4, this disk. Let's do the same thing for a function of three variables. So if we have this function that is, say, natural log of 1 plus x plus y plus z, we need to make sure the inside of this function, the inside is bigger than 0. So we'll set 1 plus x plus y plus z greater than 0, and then we can move the 1 over, and so we get x plus y plus z is greater than 1. So this is everything above a certain plane in the xyz space. So this would be the domain of that function of three variables. That's it for this section right here. Next time we'll talk about limits and derivatives.